Today I woke up and chose the violence. Today we're implementing Goto in OCaml. Let's get started. So let's start with implementing hello world, right? So let's create a file and let's do let parentheses, because this is how you define an entry point in OCaml, and let's do print and line hello world, right? So essentially it will just print the string and put hello world at the end of the output, right? And we're going to call the OCaml compiler, right? So we're going to compile this entire thing, and that should produce an executable a.out, which you can then run, and it will say hello world. It's not particularly a real executable, right? If you take a look at the file in here, it will not say that it's an elf executable. It will say that it's a script executable with binary data, right? That's kind of sus, isn't it? And this is because it's actually bytecode, right? So they're using very interesting trick in here where they just compile all of that into bytecode, and then they append shebang with a OCaml run that just executes that bytecode as a script. Right, but of course in OCaml you can actually compile into a native executable if you want to, OCaml opt.ml, right, and that will produce an actual native executable, F64 bits, LSB, blah blah blah, so the usual stuff. But for our case, I don't think it matters. I don't think it matters that much. So anyway, how would you print hello world, for example, 10 times? You know, the computer science freshman would probably write a recursive function, right? So let's create something like hello function, right? And this function will probably accept a counter, right? It will count 10 times and then it will quit. So this entire thing accepts an integer, and in here, one of the things we can do, we can check if I is less than 10, right, then we are printing hello world, and then we're calling hello I+1, right? So that's what we're essentially doing. And otherwise we're just exiting this entire thing, and then we do hello 0, right? And if we actually compile this entire thing, as far as I know, we can even just like run with interpreter without like missing the compilation step, and it should work, but it doesn't, because hello is an unbound variable. It is in fact an unbound variable, even though we just defined it. And this is because it's not visible within the function itself. To make it visible within the function, we need to mark it as a recursive, right? And only then it will allow us to do all of that. We can even probably maybe even print the number of the iteration. So to do that, we probably want to use printf, right, where we're going to do d and new line I. And then I'm going to do the following thing, but we don't have a printf because this is not a C, it's a soy OCaml. So what we have to do, we have to actually import printf from a separate module. Right, there we go. And now it actually works. Okay, that's cool. But people write code like that because they're batshit scared of for loops. But we are professional software developers. We're not scared of for loops. So let's go ahead and rewrite this entire thing using for loops, right? So I'm going to write for. I think in OCaml you do it like in Pascal, right? So from 0 to 9, do, and I'm going to take the printf, I'm going to put it in here, and I'm going to put done in here. There we go. And might as well comment out this entire thing super quick, and let's actually try to run it. And it's an error, so I think, yeah, there we go. So yeah, you don't have to put colon here because it's from Pascal. Anyway, so this is how you write with for loops. But again, both of the solutions, they kind of avoid a very important thing, and that thing is mutable variables, right? That thing is mutable variables. Again, we are professional software developers. We're not afraid of mutable variables. Let's go ahead and introduce a mutable variable like so, and rewrite this entire thing using while loop. All right, so while, so to read from a ref, we have to do exclamation mark I. So essentially, ref is a mutable cell. So the thing about OCaml is that it's kind of like a half pure functional programming language where everything is immutable, but it has some hacks that allow you to have mutable variables like ref cells, right? So, and what we're doing in here, we're creating a ref cell where we put a value 0, and to read a value from that ref cell, we have to actually put this operator, right? So it's not, right? It's dereference this value. So if you want to use not in OCaml, I think you have to do not. Yeah, so they basically made it like that. Right, so we're reading I, and while it's less than 10, right, we're printing hello world. After that, we have to mutate the variable, right? And to mutate a ref cell, you have to use the double dig operator like in Pascal. And this is why I thought that in for loop, you have to use also like a column in there, right? So what you're going to do in here, you're going to just basically read the value and add 1 in here. And there you go. We rewrote this entire thing using while loops, right? So if we try to run it, it doesn't really work because you have to read I in here. There we go. So it also works. So obviously this solution is way more superior than this soy boy computer science students comp soy. Comp soy solution, yeah. Obviously this solution is more superior than this comp soy solution, so we're gonna nuke that shit out of the code base. So, all right, that's cool and all, but there's even more Chad solution than this. And that solution would involve Goto, right? Unfortunately, being the comp soy language OCaml is, it doesn't have a Chad Goto construction. But let's actually hallucinate, like ChatGPT, that it does have Goto. How would we implement all of that? Well, first of all, I would probably just remove all of that, first of all, right? So, and I would create a label loop, right? I would create a label loop. And then at the end of the loop, I would basically go to in here. So I think Emacs have a stroke, right? Because we're using syntax that doesn't exist in OCaml, right? So we do something like go to loop in here. And we also need to have an exit condition, right? So essentially what we can do, we can say if I is less than 10, right, maybe greater or equal than 10, then we're gonna do go to out of the loop, right? So we need to create some sort of a label outside of the loop somewhere here, so let's call it out, and basically go to out. Otherwise, do nothing. Right. So, and essentially how such loop would work, right? So you initialize the ref cell with 0, then you enter the loop, you check that it's greater or equal than 10, and if it's not, you just do literally nothing, just do nothing. Then you print hello world, then you increment the iterator, and then you go to the loop, effectively repeating these 3 actions again. Right, and this time I is going to be equal to 1, it's still less than 10, so it's going to do another iteration until it becomes equal to 10, and in that case it will encounter out, it will go to the out, and it will just go in here, where we're going to print something like done, right? So let's actually print something in here to sort of signify that we're done doing this entire thing, right? And that is the most Chad solution that you can come up with. Real software developers write code like that all the time. So, but unfortunately, this is not going to compile in OCaml. Like, this is a syntax error, right? Straight up syntax error. Like, we can't even implement that thing on the level of a library. We literally have to hack the compiler to introduce all of that. So maybe we should simplify ourselves the work, right? So let's actually make it syntactically a correct OCaml, at least, right? So let's make it syntactically a correct OCaml. So what if we introduced all of that as function calls, right? So what if I said that label is just a call to label, right? It's a call to label. All right. So goto is a call to a function and it accepts the strings, right? So I'm accepting the strings in here, right? Because you know, they will not cause the compilation error, right? So they will not cause a compilation error because if I do something like this, it will say loop is unbound name and I don't even know like where to get that. So it's way easier to sort of refer to the labels as strings, right? So let's refer to the labels as strings. So I think that would make sense. All right, so this is already something. This is already an interesting approximation of what we want to create. And this thing is already technically a valid OCaml program, right? So it just doesn't have values label and values go to, right? If we try to compile this into, I think it will just say, you know, unknown label. How do you spell label, by the way? Do you spell it like label? Yeah, you spell it like label. What the fuck is wrong with me? Sorry. Right, there we go. So this is a label. So if we technically create these functions, right? So this is basically the name of the label, right? In this case, it returns nothing, and Goto also accepts the name. There we go. Returns nothing. It will compile, but it won't work correctly, right? Because all of that kind of fell through. All of that fell through. So essentially, what we need to do, we need to interrupt the control flow when we encounter Goto. So what kind of mechanisms in OCaml do we have to interrupt the usual control flow of the commands? That mechanism is called exceptions. Right. What if we made so that Goto throws some sort of an exception? Because when we encounter an actual Goto, we should not continue the execution. We should jump somewhere else. The only way to jump somewhere else we have in this comp soy language is exceptions. Right. So let's create an exception. Right. So this is how we create exceptions in here, as far as I know. Goto of and let's actually pass the name of the label, right, to which we want to jump, right? So let's actually pass it in there, and when you do Goto, we're gonna rise the Goto of the name, right? So this is basically name. Maybe I should call it a label. Let's keep it name, whatever. So let's actually try to compile this entire thing, and it's I think it's a syntactical error, right? So straight up syntactical error because you have to wrap it into parentheses, and there you go. And it has a little bit of warnings, right? Because this thing, when you enter Goto, you kind of never return, right? You kind of never return. So, okay, that's cool. So Gotos interrupt the usual sort of like way of executing, the usual control flow. So what we need to do, we need to kind of catch this exception, right? Somewhere like outside of this block. And then from that place where we caught that exception, we have to jump to either of these labels in here. Right, it would be kind of cool, right, to just do try, right, so try catch. Right, so this is how try catch looks like in OCaml. And here we would do something like Goto name, and this is we would somehow jump to either of these labels, right? Depending on what kind of name we got in here, right? So, but that's kind of difficult, right? So again, that requires Goto, but we are trying to implement Goto. So essentially, what I'm thinking is that if you look very close, labels in imperative languages generally, they form blocks. They're essentially separators of blocks of codes, right? So if you have several labels in here, so A, maybe B in here, and some more commands in here, full bar buzz, essentially each label is associated with its own block, right? So we have a block loop, we have a block A, we have a block out, we have a block B, and so on and so forth. What if we take each individual block and wrap it into a separate function and associate a name with that function? That way we can work with these imperative blocks in a functional paradigm, right? So this is kind of interesting. So let's actually remove all of that redundant stuff in here. So I put that for demonstrations, but effectively what we have in here, we have two blocks. We have loop block and we have out block. Right, so let's actually wrap the loop block with a function, right? So it's not going to accept any arguments, so it's going to be just that. So this is the first block in here, right? And the second block in here is this one, which just prints done, right? There we go. So we have two blocks in here. And probably we want to take both of the blocks and we want to put them into a list of pairs, then label the name of the block and the code of the block. Right, so let's actually try to do the following thing. Right, so this is going to be that. All right, and I wonder if it's going to be even readable. So this is the first pair, right, and this is going to be the second pair. There we go. And we can already form a list out of that, right? So we can form a list out of that. There we go. So this is the list, and this is basically the blocks. right? So this is basically the blocks that we need to execute. So, and essentially, what we want to do, we want to have some sort of engine that would allow us to start executing the blocks from a certain name, right? So essentially, we can even move the blocks out of the outside of the try catch, like completely. Let's actually try to move them in here. Right, so something like this. So this is the blocks. I wonder if I can just make it a little bit prettier if I move it somewhere here. Yeah, it looks a little bit prettier. So, and essentially, we would have some sort of a code in here, some sort of a code that executes the blocks, right? That execute the blocks. And if blocks throw an exception, we would catch this exception and we would execute the blocks again, but starting from that specific name and continue, right? So because the blocks will fall through. Right, if you continue execution from one block, it will fall through into another one, and so on and so forth. In our case, it won't, because at the end of the loop block, we have Goto loop, which jumps back to the loop. But generally, that engine has to do something like that. Right, and I'm thinking maybe we should have something like, I don't know, a function called Goto block, right, that would accept the blocks which are essentially a list of the pairs, right? So this is a list, and it accepts the pairs string and the code, the function from unit to unit, right? The function from unit to unit, and it will basically also return a unit, so it doesn't really do anything, right? It doesn't really do anything, right? And essentially, we probably want to try to move this entire code in here, right? And it's nice to have this as a function because we'll be able to recall this function in here, right? So essentially, if we caught a name, right, we want to execute Goto block again, but already on that name, right? So we would pass the blocks, but we also need to pass the name somehow, which implies that we also need to pass the name in here. Right, so as an argument, right, so this is the name, so we keep passing it, and since we basically made this function recursive, we need to mark it as rec, right? So this is basically how the engine sort of starts to take the shape, right? Right, essentially what we have to do here, we have to start executing the blocks starting from name, right? Just like iterate through the blocks, right? So we can take the blocks, we need to start iterating through them, and in here we should essentially execute each individual block until one of the blocks will throw Goto exception, and as soon as the Goto exception is thrown, we're gonna catch it in here, and we're gonna rerun Goto block, but with a new label, which will effectively jump to the next block, to the other block, not really next one, but the other one. So there is a little bit of a problem in here, right? So we have to first initially call Goto block in here with blocks, but we need to specify the label from which we're starting to execute, which is not particularly convenient because I want to execute starting from the first one. Right, so what would be the a good way to sort of resolve that? We can basically make the label optional, right? So label could be essentially optional. And essentially, if you didn't provide the label, the engine, right, so our engine should start executing from the first one. So that way we shouldn't really worry about any of that. So here I would say none, right? So this becomes none. And here I would actually pass the sum, right? Because if somebody called Goto from within the blocks, we do have a name, right? So when we sort of materialize this name in here. Right, so this is not particularly convenient in a sense that users still have to provide this none in here, right? It would be nice if none was sort of like default. Unfortunately, OCaml doesn't have default arguments. It doesn't have default arguments, but there is a trick to basically wrap everything into like an outer function, Goto block, right? Where you accept just the blocks, right? You accept just the blocks. This becomes an inner function, right? So this becomes an inner function that you then call, right? So you probably want to give it a different name, right? So it's going to be implementation. You want to call blocks and the default value of this entire thing. That way you don't have to provide this thing in here. So furthermore, we can even make it syntactically look nice, right? So we can just inline these blocks in here. right, we're inlining all of these blocks in here. And there you go. So essentially you have a special function into which you pass this block, and if we implement everything correctly, it should work like a loop, right? So you should be able to basically jump between different blocks, right? And it turns the whole thing into sort of like a state machine in some sense, right? So basically you are being in one state, and then you can explicitly switch to other state, state out or state go to loop. Or if you didn't switch to any of the state throughout the block, it will just fall through to the next state, right? It kind of feels like a little bit like a Turing machine, right? So, but yeah, essentially it's a state machine, right? That's kind of cool, right? And yeah, this is how Goto essentially works, right? It's essentially how it works. All right, so what we need to do in here, right? What we need to do in here. I'm thinking we need to distinguish between whether we have a name, right? So because name is option, or we don't have a name. All right, the easiest case is when we do have a name, right? So with some label, right? So with some, actually, the easiest case is when we don't have a name, right? When we don't have a name, because in that case, what we have to do, we have to just go and iterate through all of the blocks and call them, right? So I'm going to do blocks, and then I'm going to do a list. I'm going to iterate through this entire thing. So here we get the labels, and we don't care about the label. We're going to ignore it, but we do have a block. And what we're going to do in here, we're going to just call that block, and that is it. This is the easiest case, right? This is the easiest case. So the other case is when you do have some sort of a label in here, right? So I think we can just do that in here without any parentheses. So in that case, we have to skip like everything until we have a label, right? So basically drop the elements until you encounter the label with which you have to actually call, until you encounter the name, right? And I wonder if OCaml even have like something like drop while, like in Haskell. I don't quite remember. So let me actually see. So I want to take a look at the list. Right, so what do we have in here? So is there something like drop while? I don't think so, actually. OCaml standard library doesn't really have shit. Drop, yeah, there is no drop. It's actually kind of sad. We could try to implement something ourselves, or we could have maybe some sort of like a special function. What if we could use the name as sort of an indicator that we, yeah, so essentially we can introduce two states. In the first state, we are skipping the labels that we don't care about. And in the other state, we're executing all of the labels, right? So, and if we are in a state that skips the labels and we encounter the label that we're interested in, we switch to the state where we start executing the labels, right? Something like that. That's a very interesting approach in here. And we can use the name as an indicator which state we're in, right? So essentially, if name is not present, we are in a state that keeps executing the labels. And if it's present, that means we're in a state that skips and looks for a specific label in there, right? Something like that. So that's actually very interesting. And the iterator for this entire stuff can be the Goto block, right? I think it could be the Goto block, or maybe it could be actually internal function. I think it should be an internal function. Right, so let's try something like this. So I don't really know how to call that function. I'm going to call it go, right? And so we don't really have to pass the blocks in here because we're getting them from here. Actually, that means we don't even have to pass the blocks in here. Yeah, that's actually a very interesting idea, because we have the blocks already in the scope. We are basically capturing them from the outer scope, so we don't really need this stuff in here, which means we don't really have to pass the blocks in here, right? And we don't have to pass them in here. There we go. So we can actually simplify, like, you know, greatly this entire stuff. Okay, that's cool. So that means here, if we're going to have some sort of a go, we only have to pass the name, right? So we only have to pass the name. And essentially, if the name is not present, right? If the name is not present, we just execute. the block, the current block, but we don't have the current block, which means that we should have the blocks in here, right? So we should have the blocks in here because this function is going to be iterating through the blocks. All right. So it's going to be iterating through the blocks. All right. So, and essentially what we need to do in here, we probably need to match both blocks and the name, right? So both blocks and the name. If the blocks that we have in here empty, it doesn't really matter what kind of name we have in here, right? So essentially we should stop the execution, right? So the execution has stopped. So maybe I'm going to put unit in here and unit in here. There we go. If we do have some blocks in here, right, we usually have them in a form of name and block, right, and the rest of the blocks. And then if we don't have the name in here, right, if the name in this particular case is none, what we have to do, we have to essentially ignore the name. So maybe we can just like say name is ignored, run the block, right, and continue the execution with the rest of the blocks and non-name. Right, I'm not really sure if I have to wrap this entire thing in parentheses, right? So probably not, right? I think I shouldn't actually do that. Right, so, and let's take a look at the situation when we do have a name in here, right? When we do have a name in here. So, and let's call this name something like, so it's an entry into which we have to actually jump, right? So this is going to be an entry. So, and in that case, if entry is equal to the name, right, if entry is equal to the name, we have to run the block and essentially switch to a different state. But maybe we don't really have to do that. So we can do something like string equal name entry, right? So if we found the label, that we need to execute, what I can do, I can run go again, but essentially with this full block, right? With this full block, but without the name, which effectively switches to the state where it just keeps executing the blocks, right? Right. Otherwise, if it's not what I think it is, what I have to do is keep executing, right? Keep executing, but with some entry, right? Unfortunately, yeah, that might work actually. I think that might work. Yeah. Okay, that might work. So this is basically the iteration, right? So it will skip the blocks that we don't care about, and then as soon as it encounters the block that we care about, it will continue executing starting from there. Right, and in here what we want to do, we want to run blocks name, right? So we run blocks name. So that's rather interesting. So let me see if this entire thing will even compile. Let me just try to compile and go through the compilation errors. Okay, so this has to be multiple blocks. These go unbound. We have to make it recursive. This one is another one, and this one is another one. Right, so we call, yeah, okay, so go to block, unbound, yeah, this one has to be implementation. There we go. So, and it seems to be compiling. So if I try to now run this entire thing, will that, it worked, right? It freaking worked. So yeah, essentially if you, and what's funny is that this is implemented basically in a pure functional way. If we just close our eyes on try catch, like all of that is pure functional way, right? So it's kind of interesting, right? But yeah, there you go. So this is how you can implement Gotos in OCaml in purely functional language, but it's actually not really purely because it has states and stuff like that. But yeah, so you can think of labels as actually blocks, right? And you have a sequence of blocks that fall through each other. Right, you fall through each individual block, right? And then when you want to jump to a different block, you throw an exception, you catch the exception above, right? And then you jump to the corresponding block, right? And it's more of a like a jumping between different states, right? So it's sort of like a state machine. Right, so I think it's kind of an interesting way of looking at this entire stuff, right? So it's kind of an interesting way of looking at this entire stuff. Right, I was also thinking, okay, this particular approach works, but I was also thinking maybe to iterate all of that in two mutually recursive functions, right? So right now we have this one single go function, but what if we had, what if we split it into two separate functions that do two separate things? Like the first one just skips everything until it finds the label, and the other one just executes everything, right? So if we had something like execute, and it accepts the blocks, right? So this entire thing accepts the blocks, and it doesn't accept any name because it doesn't care, right? So it just executes all of the blocks. So in here we would do something like, we would just say it's list iterate blocks, and it's just going to be that, right? So this is the block, and we would just call that specific block, right? And we can even pipe this entire thing into this function. What's fun is that I actually been programming in OCaml for quite some time already, right? And I've been programming since this pipe operator didn't exist in a language, right? I remember the times when this operator didn't exist in the language. You guys know that? Right. And essentially, they introduced that operator after F# introduced it. So OCaml didn't really invent that operator. It's F# that invented that operator. And then OCaml kind of stole that from F#. Right, so that's kind of an interesting thing. I do remember that time. So I don't quite remember when it was introduced, like OCaml std-lib. So let's actually take a look. So the standard library should actually contain the date of introduction, or at least the version at which it was introduced. So if we search for the pipe operator, right? So here's the pipe operator. Since for 01, okay. OCaml releases. OCaml releases. So here are the releases. I want to take a look at the historical releases. So it was introduced 401. 401. Okay, so what was the date? 2013, right. But I programmed before that. I think I remember programming in OCaml 3. Yeah, I vaguely remember programming in OCaml 3, so it was in 2011. Yeah. So I programmed in OCaml at this version, and that version like really was different kind of, right? And it was different culturally, right? So things like OPAM, Dune, and some other stuff were not a thing. So everyone was using like OCaml distribution directly and everything like that. So yeah, kind of interesting. So the language suddenly evolving and becoming popular for whatever reason. Okay, so this is the execution, right? So the problem in OCaml is that you can't really have mutually recursive functions, right? Because it's a one-pass compiler, right? So essentially, if you want to call, maybe here we don't even need to have a mutually recursive function, right? Because exec is not going to call to anything that is below it, right? So something, we probably will have to only call a skip. Right, and skip is going to basically skip the names until it finds the label that it cares about, and we'll call exec. Right, so I think in that case, yeah, we don't really need a mutual recursion, right? In case of mutual recursion, right, if you want to have two functions that call each other, I think you have to put something like and in here, but then don't quite remember, but I don't think we need it in here anyway. Right, so we're going to have blocks, right? So, and in here, since we do have a name, I don't think that name needs to be option. We can just make it not option, which will actually simplify this entire stuff dramatically. So we're gonna do match. Oh, and by the way, here we don't really call exec to itself, so we don't really need reckon here. But whatever, the compiler will tell us probably. Anyway, so here what we want to do, right? We want to take a look at the blocks, right? So this is the blocks with. So if we don't have anything in here, we're gonna say that's it. We don't do anything. All right. Then we're going to have this stuff, right? So and if name is equal to, we should call it an entry, that's for sure. If it's equal to an entry, then we have to just do exec where we're gonna call this entire stuff like this, right? Without any name or anything like that. Otherwise, we're gonna keep skipping, right? So we're gonna do, you know what? I think I want to call it rest. No, not this one, but rather rest. And then here, I'm going to just do blocks, and then I'm gonna keep skipping the rest. Yeah, that's cool. And then I'm gonna here provide the entry. Right, so I don't really care about these blocks and block in here, so I think I'm gonna actually ignore it. Right, there we go. So we're gonna ignore it. And I think that's basically it, right? So I'm looking for the entry. If I found it, I start executing this, like all of the blocks, including the first one that I got in here. If it's not equal, I just skip this entire thing, right? And then, yeah, so I basically split this entire logic into two separate functions, and I think that should work. I kind of think, but we still need to have some sort of a logic that checks whether the name was provided or was not provided. Right, so I'm gonna just comment this thing out super quick. And in here, we're gonna do match name. And if it's none, we just execute the blocks, right, that we got in here, right? Or otherwise, if we have some entry, right, we have to skip the blocks for that specific entry. And that's going to be it, right? I think it's a little bit easier to understand, right? So, because we essentially split this entire stuff, yeah, it still works. So we can just go ahead and remove this entire thing. We can just go ahead and remove this entire thing. That is actually... where is the catch? Did I just accidentally... Yeah, I think I did... Yeah, I removed more than I... Yeah, so I selected the whole block, and like Emacs selected stuff including the catch. Seriously, Emacs? So that's why I was confused like that. Alright, so what I want you to do in here is just like... Imagine using Emacs in 2023, my god. Anyway, so this seems to be working. Alright. So that's pretty cool. So this is how I personally would implement Goto in OCaml, right? If you have better idea on how to implement it in OCaml, please leave a comment and let me know. I'm gonna upload all of that to GitHub and right, put the link in the description. And I guess that's it for today. Thanks who's watching right now. I really appreciate that. I hope it was fun. I hope it was educational. I hope it changed your perspective on Gotos, right? So because it's sort of like a different way of thinking of Goto, not like in terms of spaghetti, even though it still kind of is spaghetti, but in terms of, you know, separate states and transitions between the states, right? Because it's a state machine, and we're working with state machines like all the time. And that's why, by the way, Gotos like in C, they're quite useful for parsing, right? So because you have a parser that switches the states, and sometimes it's easier to just like use Goto in that specific case, right? So yeah, anyway, thanks everyone for watching, and I see you all on the next recreational programming session with Azuzin. Mwah!